Alright guys, before we get started on today's lesson 2-3, are there any questions over any of the assignments thus far? Question over anything we've done so far? No? Well, we are skipping 2-2 because going through the whole process of verifying is a little tedious, a little challenging, and doesn't impact a whole lot. I mean, it does help you get a better understanding of the formulas and how we can manipulate them to show it in different forms, but that's about it. And what we're moving on to is solving trigonometric equations. Now, there's different types or different ways we're going to solve trigonometric equations. One of them is zero product property. Zero product property is something that comes up everywhere. It's very useful, very handy. Just as a refresher, zero product property states that if we have two or more things multiplied together, here, A times B, and it's equal to 0, what do we know about the value of A or B? 0. Right, A has to be 0 or B is 0. And the way that V symbol is the mathematical way or kind of way we write it. Or technically, it'd probably be this, which is a conditional or, as we know from English, or you can have a hot dog or a hamburger, both technically, because an or statement means one or the other, or it could be both. Conditional or means it has to be one or the other. It's in most of these cases, especially with A and B, would both have a variable x in them. And the only way that it would be that A and B could both be 0, where the variable x contained in the expression worked for them to both be 0 at the same time, would be as if x ended up being the same. It was x minus 2 and x minus 2 for A and B. They'd have to be the same statement. But for the most part, it's going to be one or the other. Normally not both. But that's above and beyond. Now, the other way is actually just solving for it. Now, the main reason we would use zero product property is if we have exponents greater than 1. So we're talking about sine squared or cosine squared, tangent squared, where we have these forms there, or we're having to factor and turn it into two things multiplied together. Now, with this first one, we have sine of x plus square root of 2 is equal to negative sine of x. Well, we only have sine of x. This is kind of not linear, but equivalently to a linear equation where we have 2x plus 4, we can just solve for it. And to do that, one of the first things I would do is get our signs on the same side. So we can add sine of x to both sides. Negative sine of x plus sine of x is 0. On the right-hand side, sine of x plus sine of x, well, we have 2. Sine of x plus square root of 2. Now, since we don't have squared, we're not talking about sine squared, we can just solve for sine. We're going to get it by itself. And the first thing we can do in getting sine by itself is subtract the square root of 2 from both sides. And that will tell us that 2 sine of x is equal to negative square root of 2. Now, sine is not completely by itself. The next thing we have to do is divide both sides by 2. Questions on anything so far? Yeah. Okay. So we get to this point here. Now there's different ways we can go about solving this at this point. Now in the straight solving method, if we continued on, we need to get x by itself. So we could use inverse because we're solving for x. We're solving for the angle. So we could use arc sine to both sides and go about it that way. Or, I think the easier method, unit circle. So I'm just drawing this in for our unit circle, but I'd definitely be pulling the unit circle back out. And the reason I'm pulling the unit circle out is because, well, square root 2 over 2 is one of our unit circle values. It's one of the nice ones. And there's 4 spots where sine is or has a value of square root 2 over 2. One of them's at pi over 4. One of them is at 3 pi over 4. Another is at 5 pi over 4. And the last one is at 7 pi over 4. If we're going between 0 and 2 pi. But we could keep going further because we have 9 pi over 4. And then, because 12 pi over 4, not 12 pi over 4, 11 pi over 4. And we could keep going around. We could keep going. We have coterminal angles. But one of the things we do need to add is the fact that sine is positive for pi over 4. It is positive for square root 3 over 4. And it's negative for 5 pi over 4 and 7 pi over 8. Or not 7 pi over 8. What the heck am I right? 4 down here. So if we're wanting to find out what sine of what angle is negative square root 2 over 2, well, it's the bottom 2 here. So we're saying that x is indeed 5 pi over 4, and x is indeed 7 pi over 4. It is these two values in particular. Now, if we did this in a calculator, we did sine inverse, and we'll need it in radians, because when we solve, especially for an angle, we need our answer in radians. Get this here, which is negative pi over 4. Now, I'm going to add 2 pi to it because we really want our answer in positive angles. 7 pi over 4, found it on the unit circle. This is what we have. Now, I'm going to look back at the top. We'll scroll back to this here in a second. This just tells us to solve. So we need to find the angles that would make this true, yes? Did we find 2 angles that make it true? Say I added, so we have 5 pi over 4, yes? Well, I'm going to use the calculator. I'll use 7 pi over 4. Let's add 2 pi to it. 15 pi over 4, yes? So if I took sine of 15 pi over 4, what will we get? Negative square root 2 over 2. Well, it works out that if I continue to add 2 pi to 7 pi over 4, I will continue to get negative square root 2 over 2. Well, all of those are still true, yes? Well, it actually works out that 5 pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n will give us true statements. Now, n can be any number, or really any integer. We don't really look at fractionals. It's going to be an integer. So 1, 2, 3, 4, 5, or negative 1, negative 2, negative 3. And we get those here. Now, it might seem weird. When are we going to add 2 pi in? When are we not? whenever it says solve, we're going to have to add it. Now, there are some cases where we can change it a little bit, and I'll point those out. But if it says for or when x, solve this when 0 is less than x is less than 2 pi. Normally, they would probably put equal to on one of them. Either 0 is less than or equal to x is less than 2 pi, or 0 is less than x is less than or equal to 2 pi, because 0 and 2 pi are the same angle, so we'd have one and not the other. But if it does give us this restriction of x, the value of our angle being between 0 and 2 pi, then that's all we have. We don't have to add the 2 pi in because we have restrictions on what it can be. But since this one here just said to solve, we need to find every x that makes this statement true, and it's defined by these two here. Questions on this here? We ready for the next one? Cosine of x minus square root of 2 equals negative cosine of x. Well, this is essentially the same thing as the last one. So the first thing I'm going to do is get the cosines on the same side. And if we add cosine of x to both sides, we get 2 cosine of x minus the square root of 2 is equal to 0. And just like the last one, we can add the square root of 2 to both sides. Well, almost. On the last one we subtracted. So we had 2 cosine of x equals square root of 2. At this point here, we can divide both sides by 2, telling us cosine of x is equal to the square root of 2 over 2. Now again, just like with the first one that we just did, or the last one we just did, square root of 2 over 2, that's on the unit circle. And I would be referring back to it there, because on the unit circle, it does tell us that cosine does equal the square root of 2 at pi over 4. At pi over 4, it is positive square root of 2 over 2. And at 7 pi over 4. But again, because we are not restricted on what the values of x or our angle can be, we have to add the 2 pi in to it. Questions on this here? So one of the things you're definitely going to be needing, definitely is going to be handy, is the unit circle. It's really going to help you with these here. Any questions on any of these here? Three tangent squared of x minus 1. Now this is where we're going to have to start using either our zero product property or other solving methods. Well, it might not be directly obvious for this one here, but we can use the square root method for solving. And square root method, so if I said we had 3x squared minus 1 equals 0, well, looking at this here, we have no middle term. All we have is the x squared term and our constant term and leading coefficient. Well, what I would do here is I'd first add 1 to both sides, telling me 3x squared is equal to 1. Divide both sides by 3, Tell me x squared is equal to 1/3. Then to get x by itself, I would take the square root of both sides. Tell me x is equal to plus or minus square root of 1/3. And we could type this in a calculator, but do make sure to type it in individually, because the yellow calculator does not like trying to do the square root of 1/3. It won't get it back. But if you do take the square root of the numerator divided by the square root of the denominator, it will simplify it, which simplifies to this here. Questions on what we did with that there? Well, it's the same thing over here, because we can start off by adding 1 to both sides, telling us that 3 tangent squared of x is equal to 1. And we can divide both sides by 3, telling us tangent squared of x is equal to 1/3. And we can take the square root of both sides, which will tell us that tangent of x, because the square root and square cancel, equal to plus or minus the square root of 3 over 3. Well, we know it's the square root of 3 over 3 because, well, we simplified it on the other side already. Now, here we're saying that tangent is equal to plus or minus the square root of 3 over 3, positive or negative, yes? Well, on the unit circle, we aren't technically given tangent outright. We are given tangent, it is there, we just have to calculate it. We have to do sine over cosine. Now, I did give you, I think on the back, that nice little big chart that we filled in. And if we look at it, tangent is square root 3 over 3 at pi over 6. That's our 30 degrees. Well, we can look at all the others that are 30 degrees that are positive and negative, because we're saying that this is true for square root 3 over 3 and negative square root 3 over 3, yes? Well, that's all of them, isn't it? That's all the ones that it could be, because we eliminated 2 from the previous 2 because we only had a positive or negative for sine or cosine. Here it wants both. So the next one would be at 5 pi over 6. And this 5 pi over 6 would be negative. And then we also have it at 7 pi over 6. And lastly, we have it at 11 pi over 6. Because our 11 pi over 6 and 5 pi over 6 are our negatives of this here. 7 pi over 6 and pi over 6 are our positives. And again, because we're not restricted on these angles remaining between 0 and 2 pi, we have to add 2 pi into it. So our answer is all this here. Questions on any of this here? Now you don't have to draw this out. Technically, these are a little, might be a little big. 5 over 6, 5 pi over 6. So these are the 4 angles that we have, where tangent is either positive square root 3 over 3 or negative square root 3 over 3. Yes? Well, what's interesting is that to go from pi over 6 to 7 pi over 6, that angle is a measure of pi, yes? Oh, I need another color. From 5 pi over 6 to 11 pi over 6, that's also an angle of pi, yes? And this is kind of odd that it does work this way, that if I added pi to pi over 6, we would get 7 pi over 6. If I added pi to 7 pi over 6, we would get to the coterminal angle of pi over 6, yes? We would keep kind of flipping back and forth. So what works out is that our 5 pi over 6 and 11 pi over 6, these two statements here, can be simplified to x equals 5 pi over 6 plus pi n. Because they flip that pi and both of them are there, we can just write it as pi n because it'll go from one to the other. Incidentally, because pi over 6 and 7 pi over 6 are also a distance of pi, we can say x is equal to pi over 6 plus pi n. So if you write it as the four statements, that's correct. If you simplify it to these two, that's technically also correct. Does that make sense? And some of that, it's when you see it on the unit circle that, okay, we're jumping between these two, we can rewrite it as pi n instead of 2 pi n. But if you're not sure, you fall back to the 4. If you're not sure that you can reduce it, stick with the 4 statements. Questions on this here? Are you ready for the next one? 4 sine squared of x minus 3 equals 0. Well, we're going to treat it the same way that we did the last one. This is a square root method problem. So we need to get sine by itself. And the first thing we can do is add 3 to both sides. Find us at 4. Sine squared of x is equal to 3. What can we do next? Almost. I mean, we can, but I would divide by 4 first. Because it would work here, it would actually kind of work out nicely. Mainly because the 4 in front of sine and sine squared would simplify nicely. But it'd be better to get sine by itself first before we square root. Square root both sides. And the square root of sine squared would be sine of x is equal to plus or minus square root of 3 over 2, yes. Because 3, we can't take the square root of 3 and simplify it to a nice number, so we leave it as square root of 3. And the nice thing with 4, square root of 4 is 2. That's why I said on the previous step it wouldn't be wrong to take square root, because when we did, we would have 2 sine of x is equal to plus or minus square root of 3. Then we'd have to divide by 2. We'd still get there. It's just if it was, say, 5 sine squared of x, then it wouldn't work out to be a nice number, and we'd have to go from there. Now, they're still being nice to us because, unit circle again, sine does have a value of square root 3 over 2. And the first one is up here with pi over 3. Next one's over here, negative square root 3 over 2 with 2 pi over 3. Then we have down here with negative square root 3 over 2 with 4 pi over 3. And our last one down here positive square root 3 over 2, and it is 5 pi over 3. So we have these four here, yes? Now, we actually want positive and negative, which means we want all four of those. So we have pi over 3 plus 2 pi n, 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. So all four of those are solutions for this here. Questions on this here. Now, because we do have this positive, negative, both sides work, we can actually convert these top two to x is equal to pi over 3 plus pi n, and we can convert the bottom two to x is equal to 2 pi over 3 plus pi n, because we're jumping from one to the other. Questions on this here? Now, unfortunately, there's no way to convert those two statements into one without getting it to be a little weird. We'd have to use pi over 2n, pi n over 2, because then we're adding 90 degrees, but then it gets a little weird. All right. Any questions over any of this so far? Most of it's been pretty nice so far. Sine, cosine, we don't have powers. It's all in terms of sine, all in terms of cosine. Get them by itself, solve. Squares. So far we've had some nice ones. The square root method, get sine squared, cosine squared, tangent squared, secant squared, cosecant. Get it by itself, square root both sides, and solve from there. Now this is the first one that we have that's a little different. We have cotangent times cosine squared of x is equal to 2 cotangent of x. Well, we have different terms. So one of the first things I would definitely do, especially since we have cotangent or cosine squared, we've got other terms, is to get it equal to 0. 0 product property. Now to do that, we can just write underneath it. We don't necessarily have to rewrite it. I'm going to subtract 2 cotangent of x from both sides. Now on the right-hand side, we will have 0 because these will cancel out. Now on the left-hand side, cotangent times cosine squared of x and negative 2 cotangent of x are not like terms. So that just means we're going to have cotangent of x cosine squared of x minus 2 cotangent of x. We're going to get them together. Everything on the same side equals 0. Now, according to the zero product property, whenever we have two or more things multiplied together to equal 0, one of them must be 0. Yes? So we'll have to do some factoring. Is there something in common with both terms? Cotangent. So what we can do is we can factor cotangent out. And if we factor cotangent out, we'd have cotangent of x, parentheses. If I factor it out of this first term, we're just left with cosine squared of x, minus. Factored out of 2 cotangent of x, we're left with 2. Questions on how we got to this point here? Now, at this point, we do have two things multiplied together to equal 0, so one of them must be 0. So we're going to say either cotangent of x is 0, or cosine squared of x minus 2 is equal to 0. Now we can finish solving cotangent of x first. I'm going to write this underneath it. Cotangent of x for the unit circle is the x value over the y value. And for this to be 0, we need the y value to be, we need the x value to be 0, and we need the y value to be a number, some number other than 0. Well, incidentally, the only time that this does work is if the y value is either positive or -1. It's got to be one or the other. And we can look at the unit circle because it is given to us in points, x and y. Well, the x value is 0 at pi over 2. And the y value is positive 1. So going straight up 90 degrees, we would have cotangent of x being 0. Incidentally, tangent's undefined. Because if we flipped it, we would have 1 over 0, which does not work. Our other spot is straight down at 3 pi over 2. Because it's straight down, x is still 0, y is -1. Those are our two values. Does this make sense? But again, we are not restricted on the values or our angles between 0 and 2 pi, so we have to add the 2 pi in. So we have these here. Questions on these so far? Cosine squared of x minus 2. Well, we need to solve this, and the first thing we can do is add 2 to both sides, which tells us cosine squared of x is equal to 2. At this point here, we can take the square root of both sides, telling us that cosine of x is equal to plus or minus the square root of 2. Is that on the unit circle? Yes. Well, no, because our only square root of 2 ones is at 45, and that's square root 2 over 2. So we can use our cosine inverse from here, because we'll have two statements. So we're saying cosine of x is equal to the square root of 2. We also have that cosine of x is equal to negative square root of 2. At this point here, we're going to use cosine inverse of both sides, because cosine inverse of cosine of x is just x. And that's telling us it's equal to cosine of inverse of the square root of 2. So I can grab the calculator, say second cosine inverse of second square root 2, and we get this nice angle of, okay, before you're back, okay, so that threw up an error. Let's see why. We said that cosine or sine of any angle can be at most 1 or -1. It can't be bigger or smaller than that, just of cosine itself. And if we look at square root of 2, as a number, it's 1.4 going on. That is too big. There's no way to make cosine of x ever get to be square root of 2, let alone square root of -2. So this side is not possible. There's no way to get cosine squared of x minus 2 to be 0. Because even if we look at this here, the biggest value cosine of x could be is 1 or -1. And even if we square it, 1 squared is still, -1 squared is +1. There's no way to make that 0. Does that make sense? Because even if it was 0.99, we got cosine to be 0.999, and I square it, it's still not bigger than 1. So this other side is not possible, but we still have an answer. These still work. So it could be, especially when solving, when we start doing these solving, some of the parts of the equation will give us no solution or not possible because we couldn't find a value that made cosine squared of x minus 2b 0, but we do have it for cotangent, and one of them is pi over 2. And we could check it because we could say cotangent, which is 1 over tangent. So we can say 1 over tangent of pi over 2 times cosine of pi over 2 squared, and see what we get. Yeah, we can do it. It's just going to be fickle about it, mainly because cotangent of pi over 2 times cosine squared of pi over 2 is equal to 2 cotangent of pi over 2. The calculator is going to throw an absolute fit over this, or at least the 30XS is, because tangent of pi over 2 is undefined. There is no value for it. That's why I threw a fit. But cotangent of pi over 2 is 0. Now our cosine squared, 0. Now cosine of pi over 2 is 1. And we have it squared. Is equal to 2. Our cotangent of pi over 2 is 0. Right. Cotangent squared. Or cosine, no, sorry, this is also 0. This whole side becomes 0. 0 is equal to 0. And we can do the same thing with 3 pi over 2 and get the same result. Now it seems odd that pi over 2 doesn't work for our cosine, but because of how when solving we didn't just get cosine equals 0, we got cosine squared minus 2 equals 0, so we don't have an actual statement. Does that make sense? It's kind of a little weird, but it does work out. Questions on any of this here? Well, we're going to stop there for today, mainly because we're out of